So we've gotten to the point where we're starting to square our boards and learn that process, but I've got one nice smooth side of my plank, but now I need the other one to be smooth. We never use a jointer on both sides of a plank, and here's why. Let's say this piece of paper is a plank of wood. You assume that from the mill that the planks are not square. They don't have parallel edges and sides. So here's our plank. So I'm going to take this end. I'm going to put it through the jointer. And we remove a layer from there. So now if I want a smooth side, if I try flipping it and I put it through the jointer, and I get rid of that other side. It's gone through the jointer. Are the edges parallel? No, they're not parallel because we have referenced the edge that we are cutting when we're trying to joint it. In order to make your plank parallel, you need to run it through the jointer, and then you need to use this edge to then make the other side parallel. We do this with a table saw. Now, a table saw is one of the most dangerous tools because of the nature of it. Now, it's a very tricky name. It is a table with a saw blade hanging out of it. It's pointed upward. It's, you can just drop your hand, cut your hand right in half. And most injuries come from this tool. I have never lost a finger, and my goal is to make sure you never lose a finger as well. All right, let me get my plank of wood. So, wait a minute. No, I joined it. I'm right back. All right, so here's my plank. I've got a smooth edge that I already jointed, and now I've got a rough edge right here. We are going to use this jointed edge on the fence to guide our cut straight through the table. Just like the paper, this is the end that I jointed right here, right on the fence, and here's the one I'm going to cut with the table saw. This is called a rip. That means I'm cutting with the grain. Let's see. So the first thing that you want to do when using a table saw is set the height of the blade. Okay. To do this, while the tool is off, I put my workpiece near the blade, and I'm going to use a wheel. When I go clockwise, it goes up. When I go counterclockwise, it goes down. So I'm going to raise this blade until it is above the surface of my workpiece. How high should I raise the blade? Well, really the question is, how much of your finger do you want to cut off if you make a mistake? Right now, if I were to really not pay attention, and I decide I'm going to put my hand flat and cut this way, it will get maybe 1/8 of an inch into my thumb. I say it should be no more than 1/4 of an inch. Basically, I feel like it cuts smoother when it's higher up and it's closer to the gullet of these blade tips, but keep it under 1/4 of an inch above the surface of your workpiece. So we've set the height of our blade. Now what we want to do is set our fence. To set the fence, you're going to just lift up your knob and you're going to guide it over until it lines up with either any lines that you've drawn on the workpiece or you like the way that it lines up with the blade. Once you have it set, lock the fence. You push it down. Some of these rails come with grading, like inches. In general, draw your lines. Measure with a pencil and a ruler, and then make sure that it lines up, because sometimes these machines are off, and just being a little off can really affect the quality of your product. Okay, So I set the blade height, I set the fence. Here's a concept that you need to understand. The forces that you have to exert on your workpiece. You want to be pushing it into the fence, down towards the table, and forward through the blade. All three forces must be present, or you are in an unsafe position to cut. To achieve this, I treat it almost like a pool cue. My left hand is, I place it on the table and I push. I put it on the table and I leave my hand so I can push inwards. I never, ever push in from near the blade. If I start cutting and I'm halfway through like this and I push in this way, I'm going to be pushing the extra wood that's loose into the blade, pinching the wood on the metal, and that's going to cause kickback. I'll mention kickback in a minute. So, my left hand is on the table pushing in. My right hand is almost like it's like, yeah, I do this. So my thumb is going to be positioned on the back of the board because I have some really good control with the forward motion. Left hand like this, pushing this way, right thumb on the back. Fingertips are going to push downward. So I have achieved inward, downward, and forward motion. Now, kickback is what makes this dangerous. And kickback happens when the workpiece gets lodged between this rotating metal blade and this metal fence. This is not going anywhere. So if there's a pinch point, this rotating blade will grab and launch the plank. Now, I had a professor who used to do a demonstration. He'd toss a piece of wood into the blade while it's spinning. And he stopped doing that because it broke a window. A lot of horsepower in this blade. It's spinning really fast. So, to avoid kickback, you exercise flat on the surface, flat on the fence, and you are guiding it with those hands. Kickback. So if it were to twist and get caught in the blade, it's also going to knock your hand, which is on the workpiece. And that's what happens. Your hand can get knocked into the blade faster than you can register any pain. Some fun numbers. The blade rotates 4,000 RPM, rotations per minute. The blade has, I think, 88 teeth on it, and your response time is 0.15 seconds. That's a physiological response to pain. So in the time that it takes for you to just naturally pull your hand back from pain, I think it's like a couple hundred teeth will eat into your hand. A couple hundred of these little saw teeth are going to eat into your hand, and that's before you even knew you got cut. So any kickback is super dangerous. Now, let's see. So I've set my height. I'm setting my fence. Please fit with the computer. Okay, good. I'm checking that it's flush or flat to the surface with no gaps. I've got my fingers pushing in. I've got my thumb pushing forward. I've got my fingertips pushing down. I'm going to stand to the side as well. When I'm cutting, I never cut like this, because if it catches, it's going to launch it back into me. Stand to the side with your right foot forward. That way I can reach with my shoulder. I've got a lot more extension here. And this is critical because as you're pushing, you want the piece of wood to pass all the way through past the blade. You want a slow, controlled movement while you cut. I'm going to execute a cut now, a rip. I think you can see. Can you see? So now, with the help of my handy dandy planks, you can see the cut as it's happening. If I do it like this, you'll be able to see when I let go. So I got everything set up the way it needs to be. I'm standing to the side. I've got my right foot forward so I can push all the way through the cut. I'm going to try and keep my hand out of the way, but I really want to be safe as well. I'm going to turn on the machine with the wood away from the blade. Hand on the table. I'm pushing in. I'm going to start cutting. Now I remove my hand. And keep going. Now I'm free. So I removed my hand once it was no longer safe for my hand to be pushing this way. So you remove that. And what's nice is at a certain point, the blade itself will help guide it towards the fence. You want that right hand to not push it into it, but just follow that fence. It's smooth. It's designed to keep you safe. And you only release once that piece of wood is fully cleared. Here we go. Yeah, you can see. So fully cleared. Not yet, 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 not yet. Okay, now I can push it forward and remove my hand. If you let go, there's a lot of movement. It could actually have some negative pressure that pulls the workpiece towards the blade, and that could also cause the workpiece to get launched to you. So once again, set the height of your blade, set your fence, stand to the side with your right foot forward. Use two hands or two push sticks. I'll show you push sticks when we have them available to you. Hold it here, and you are going to guide your hand with your thumb on the back, fingers pushing down entirely through the cut. If the workpiece is 4 inches or less, you need to use a push stick. If it is wider than that, then you can use a hand. I will be watching you. I am going to tell you if there's a situation where you are not comfortable. Have a great day.